What is the area of our shaded region? We have a figure here. We have a quarter circle, a big one. A, B, C is a nice big quarter circle. And then we have a smaller circle inside of that. And we have a length of MN we're given, which is 2. Right here, that's the tangent of the smaller circle. And just so we know, BOM becomes a straight line. It's all within the same line, okay? Which is that information we want to, well, find the area of this shaded region, basically that quarter circle minus the little circle, all right? Let's pause this video, see if you can get an answer. But as always, we're gonna go dive on in to our solution, okay? So I kind of said in the beginning here, the goal of this is to find that area by finding the quarter circle area minus the little circle in here. Let's get some information labeling here because we don't really have many values. We only have the value of 2. Well, let's go say our radius of the little circle. Let's just draw a little line here. And I'm going to call that little r. Our big circle, if it was continued, would have a radius from C to B or B to A. Let's call that big R. Okay, so CB is equal to big R, which is equal to AB. All right, let's make a little note of that. So the formula for the small circle, area of the small circle, is going to be pi r squared. Pi little r squared, and it's unit square. The big circle, or large, I use area of the large circle, the larger one, is going to be the same thing, pi big R squared. And our quarter circle, area of the quarter circle, I'll put a little Q there, is the same thing, pi R squared divided by 4. Because remember, it's a quarter of that, okay? So our shaded region, area of our shaded region, okay, is going to be the area of the quarter circle, pi big R squared over 4, minus the area of the small circle, pi little r squared. And we can pull out, well, the pi, and so we have it's equal to pi times a big R squared over 4 minus a little r squared. All right, so we kind of set the groundwork here for that. So now let's go draw a line from D, O to E. Let's go straight down here at our point of tangencies. So it goes to the center, goes down right here. D is a point of tangency, E is a point of tangency. And tangent to a circle theorem says that this must be a right angle, not the best right angle, but it's a right angle. And we also know then that this is a right angle here, complementary, or supplementary actually, right there. And again, circle, quarter circle, right angle here, keep on going, right angle. We have a rectangle, not necessarily draw to scale, bear with me, but we have a rectangle nonetheless, meaning the opposite sides here are congruent. Well, since this side of the rectangle is the radius plus the radius, or 2 radii, we can have that here, 2 little r's length of n, b. And since mn is length of 2, we can connect now b to m, like I said in the beginning, goes right through the center of the circle, right there. And that length of mb is equal to, well, the radius again, right? Of the big circle, same radius. So we actually can use Pythagorean theorem, okay? Now watch this. Mn, length of 2, 2 squared, plus nb squared, 2 little r, all squared, is equal to this large radius of the circle squared, big R squared. So now let's go simplify that. We have a 4 here plus 4 squared, or 2 squared is 4. 4r squared is equal to big R squared. And if I divide all parts by 4, both sides, everything by 4, we're allowed to do that in math, right? We have a 1 plus 4's canceled, r squared equals big R squared over 4. Bring the r squared over, and we have 1 equals r squared over 4 minus little r squared. And look what we have here. That is right here, exactly word for word what we found for the area. So the area of our region, instead of this r squared over 4 minus little r squared, we replace that with 1. Pi times a 1, which you know is just a pi. We can put the unit squared on it. And that's it. This whole thing was set up just to have an area of our region of pi. I hope you got that answer. If you didn't, I hope you learned something here. And as always, thanks for watching.